hold on, what actually is the quadratic formula?
Math fan Owen, I know. It's an equation you can use to solve quadratics when you know what a, b, and c is, but you don't know what x is.
Timmy, shut up. I already know that.
What I'm wondering is where it comes from and why it actually works.
By the way, if you don't know what the quadratic formula is, I have a video explanation of it right here.
What we're going to do is start with the standard form of a quadratic equation. What we need to do is solve for x in terms of a, b, and c. So let's move the constant to the other side of the equation. Now we're going to complete the square. We'll divide every term by a so that the x squared term doesn't have a constant. And now we'll complete the square by adding b over 2 squared to each side. Since the coefficient of x is b over a, we'll plug that into b over 2 squared, and we get b squared over 4a squared. So now we'll add that term to each side of the equation, and then we can factor the left side into x plus b over 2a squared. Now that we've completed the square, we just have to isolate x and simplify. First, we're going to take the square root of each side of the equation. When you take the square root of the left side, you need to include the plus or minus to make sure you account for both solutions to the quadratic. Now we'll just manipulate the constant term under the radical so we can combine both fractions. We can also simplify the denominator of the radical to 2a, and then we subtract b over 2a from each side to finally isolate x completely. And what you'll see is now that we've isolated x, we get the quadratic formula.
So the quadratic formula came from the standard form of a quadratic. And the reason why it works is because I did the math right.
But seriously, the point I'm trying to make is that it works because it's derived from the standard form of a quadratic. Since it's derived from the standard form, it works for any quadratic, no matter the values of a, b, and c. So that's it.